1.4, we're going to describe behavior of graphs. This stands for average rate of change, and there's going to be extrema in graphs. So after you filled out your template on this right here, if you could please, we are going to draw an odd function. I know that is a positive odd function because that graph is up on the right. So if you notice this graph, we're going to say it's increasing because it is read like a sentence from left to right. So when I start on the left side, I know that this graph is increasing because it moves from the bottom to the top, and we're going to talk about how it's increasing, but we only talk about how it's increasing based on an interval. Now I asked you to leave these two lines blank on purpose because an interval, again, is only the x values. It is x values explaining the attributes of a graph. Attributes of a graph. All right, so I know this graph is increasing. It is actually going to be increasing forever from where I see it starts, and it starts on the negative infinity arrow, and it's increasing forever to positive infinity. So that's how we're going to describe this graph right here. All right, and then on the flip side, of course, the graph can be decreasing. So this time, I'm going to have an arrow up over here where negative infinity starts. And then this is going to go down forever. Please note, this is an odd function. I know it's an odd function because the arrows are going in opposite directions. So as I am reading this graph, and remember, you read it just like a sentence from left to right, I notice that this graph is increasingly going down. So as I start from the left, go to the right, I can see it's going down. So we're going to say that this graph is decreasing from negative infinity to positive infinity. And then, of course, you're going to have something where nothing happens at all, and that's going to be your horizontal line. So remember, that is a function. It does pass the vertical line test, but it is constant. And we still read it from left to right. So as I start on the left, this is negative infinity for x. And all of these x coordinates are increasing. They are increasing, but if you notice, the y value is constant. Whatever that y value is, it's above the origin, so I know it's a positive number. But the way we're going to say this, it is constant from negative infinity to positive infinity, because an interval are x values only. This is continuously constant forever. So now let's go ahead and talk about the graphs that you have glued down. So if you notice, there's a lot going on here, and we're going to talk about what's going on here based on the x coordinates. So I asked you to leave 3 lines here on purpose because we are going to talk about where the graph is increasing, and I'm just going to abbreviate. We're going to talk about where the graph is decreasing, and then we're going to talk about where it's constant. And I'm just going to copy these 3 lines all the way across for each of my examples. All right, so here we go. If you notice, the first thing I see right here is going to be a negative infinity arrow. And as I trace, I notice this graph is continuously going up, but not forever. It's going to go up to that value right there. And that value is where x equals 4. So this graph is increasing from negative infinity all the way up to that negative 4. And then I am going to leave some space because it's also increasing right here. But let's just kind of analyze as we move from left to right. So if you notice, I did not draw a bracket right there because at that exact point, there is no change happening. Negative 4 is like at a standstill before it changes direction. So I'm going to pick up where I left off right here. So if you notice, this is a horizontal line all the way up to this point. And that is going to be constant from where x is negative 4. Look, it's crossing the origin. And it looks like it's constant right there at x equals 2. So this is where that part is constant. And then it starts falling. So right where positive 2 left off, we're going to pick up because where x is positive 2, it starts decreasing all the way down to this point. And remember, that point is where x equals a positive 4. Now, I wish I would have wrote just a little bit smaller on my increasing line, but that's okay. I'm still going to make this part fit right here. So remember, we're going to use our U symbol. Now, after we take off where x equals 4, it's going to go up forever. So it is also increasing from 4 to positive infinity. All right, let's take a look at the next graph real quick. So we're going to read it like a sentence from left to right. The first thing I see is a negative infinity arrow, but the graph is going up. So I'm going to start right here on my increasing line. So this is going to be from negative infinity, let's see. It looks like to about right there, and that is the origin. So that is going to be increasing from negative infinity to 0. But I have this little dip here. So I have to make sure I record this movement also, and that's decreasing. That is decreasing from the origin at 0 all the way down to where it looks like x equals a positive 3. So it went down right here. But look, it's turning around and it's going back up. So I got to go back to my increasing blank that I drew. Now remember, it turns around at positive 3. So after we pass 3, it goes up forever. And there was not any constant value here, so I'm just going to write none. It wasn't constant at all. All right, let's take a look at what's going on over here. So remember, this is just interval. Oh, it's off my screen. Just intervals. We're just talking about the x values. So it might appear like it's interval notation for domain, but it's not. It's just describing the behavior. All right, here we go. So reading my sentence, my graph sentence from left to right, the first thing I see is a negative arrow, but the graph is going down. So this graph is going to be decreasing from negative infinity all the way up to whatever x value this is. And this x value appears to be negative 1. And then we're going to pick up again. Now remember what I said, it's not interval notation for a range. So I'm going to pick up where negative 1 jumps down to here. And if you notice, this is constant. So this is all constant right here. So this is going to be from negative 1. There's my positive infinity arrow. And this graph did not have any increasing components. All right, so let's go ahead and talk about the next part, which is going to be, still the wrong button, average rate of change. All right, so for average rate of change in 1.4, this is the most missed part, and it should not be, so please pay attention. In this box right here, what I asked you to draw that for is because I'm going to abbreviate. Average rate of change is just the change in y divided by the change of x. That's all it is. I'm not giving you that formula anywhere on a test or a quiz. However, the change in y over the change in x, y'all, that's slope. And I know that you know slope. That's like an algebra 1 thing. And remember, for slope, it is going to be y2 minus y1 divided by x2 minus x1. Same exact formula, but if you remember it's this, it might go a little bit quicker for you and you wouldn't be worried about memorizing a formula.